Alright, here we go with section 12.2, mean and standard deviation. This actually kind of be a combo of 12.2 and 12.3 because it's all the same thing. The goals for this lesson are to calculate the mean and standard deviation for a set of data. So some notation things here, and this is going to be a majority of what we talk about here in this brief unit. So instead of saying the word mean, writing out the word mean, in stats we use symbols. We can use X with a little bar above it, or this little funny looking U thing, and you can see their names right here. So we literally call the first one X bar, and the second one's mu. And these represent the mean. Hopefully you know how to find the mean. It's the average of the numbers. I'll show you again what that's going to look like in statistics symbols. It's going to look more complicated, but don't overthink it. You know how to find the mean. Now, this next part you might not know how to find. You might have heard of this before back in Algebra 1, I believe it was. But we use S, or this funny-looking O thing, which is called sigma. Those both represent standard deviation. So we have X bar and mu represent the mean. S or sigma represent the standard deviation. So some formulas and definitions. So a mean is just the average that uses the exact value of each entry. So you're probably looking at this. This is how you calculate the mean. You're probably looking at that and you're like, what in the world? Okay. Well, first of all, like I said, to find the mean of any set of data, you just add up all the points, divide by however many pieces of information you have. What this little thing means right there, that little E looking thing, can't even draw it, little E looking thing, that, put little quotations around it, that means sum. So it's telling you to add up all the x's, those are your data points, then divide by n. N is the number of data points. So exactly how you probably would describe the mean, you add up all the pieces of information, divide by how many there are. That right here is just the same thing in statistics notation. Now again, standard deviation, we talked a little bit about this in Algebra 1, but here we get a little bit more in depth. We learn how to calculate it by hand briefly and how to use the calculator. But standard deviation, what that is used for is to describe the spread of the data about the average. So we'll talk a little bit more about that and how that is useful when we jump into 12.3. But here's how you calculate. So we have sigma equals the square root of, and then here's that funny looking E thing again, right here. That funny looking E thing just means sum. So the sum of, you take your data point, subtract the mu means mean. So you take your data point, you subtract the mean, you square it, you divide by n, where n is the number of data points again. Or the difference between the first one here and the second one is the notation. So we have mu here, here we have x bar. Both of those mean the average. So they're just showing you, I guess you could see it either way. So some of these calculations will take a lot of work when done by hand. So we're going to do one by hand. You can see here right below there are 6 pieces of information. And you'll see how much work it is for 6. And then we'll do the rest by calculator. So I will show you how to do that. Make sure you know how to use the calculator, because that's like the majority of what you're going to have to do is just understanding the symbols and being able to use your calculator for the basic statistics unit that we're about to cover here. So find the mean and standard deviation by hand using the formulas and the data provided. So first of all, I want to find, see if I can write this out here, mu, or x bar, or the mean. So I take the sum of all the x values and I divide by how many pieces of data I have. So the sum would be if you had 2 plus 3 plus 3 plus 8 plus 10 plus 10. So if you add up those 6 data points, 2 plus 3 is 5, plus 3 is 8, plus 8 is 16, plus 10 is 26, plus another 10 is 36. You divide by how many values you have, so 1, 2, 3, 4, 5, 6. 36 divided by 6 is 6. So your standard deviation, or your mean, or mu, is 6. That's the average of those numbers. Now the next one, here we go. This is going to take a little bit of work. We are going to find sigma. So here's how this works. You have to take the sum of the x value minus your average, which I'll write as mu. You could write as x bar. Then you have to square it. So we're going to start here. So here is a lot of work, even for just 6 points. So you start with your first number, 2, subtract the mean, square it. Okay, so that's what that means. But you have to do that for each data point. So then plus, because we're adding, that's what that little e means, the sum, plus, now you take your next point, 3, minus the average, the mean, and square it. Plus, now take the next one, the second 3, so 3 minus 6 squared, 3 minus the mean, plus, take 8, so we'll go 8 minus 6 squared, plus 10 minus 6 squared. So you go through and you take each data point, you subtract the average, and you square it. That's the first part. We have one more, so plus 10 minus 6 squared again. So let's add these up quick. So 2 minus 6 up here in the front. 2 minus 6 is negative 4. Negative 4 squared is positive 16. 3 minus 6 is negative 3. Negative 3 squared is 9. So we get another 9 here. 8 minus 6 is 2. 2 squared is 4. 10 minus 6 is 4. 4 squared is 16. And then we get another 16 here. So you add all these up, and we end up with 16, 9, 34, 38, 58, 70. So we end up with 70. And you can also use a calculator for that too. That's fine. Okay, but if you go back up to the formula, so all we found was this first part here. We took the sum of each x value minus the average, and we've squared it. We ended up with 70. So now we need to take the square root of that number that we got, 70. Then we have to divide it by n, however many data points we have, which is 6, we said. So you're going to have to bust out the calculator for this one. So the square root of, let's go, square root of 70 divided by 6, missed the 7, is 3 point, we'll go 42. 3.42. So that is your standard deviation. So we found our mean, we found our standard deviation, we calculated by hand. So again, you can see, if I scroll down to the next example, we'll find this example by hand. But if I scroll down to actually example number 3, look how many data points we have here. Up here we only had 6. Here we have way more than 6. Calculating the mean would still be the same. It'd obviously be quite a bit of work. But still doable. Now imagine calculating the standard deviation. We have to take each single point minus the average. You'd have to take this minus the average squared, and then this one, and this one, this one, this one, this one. You just keep going. It would take forever. So let's talk about how to do this on the calculator. So this is probably going to be the most important part here, because not often you're going to find yourself calculating mean and standard deviation by hand. So let's take the same 6 data points. We know what the mean and the standard deviation are, 6 and 3.42 if we round. Let's see if we can get the same numbers on the calculator. So let's open up Calculator Pro. Okay, first thing, if you have stuff typed in your home screen here, that's fine. You can clear it. It doesn't matter. But where we want to go is to stats. So if you look at the alpha button and you go 2 over, it is right above kind of sine and cosine, above, 2 above. And then it's going to bring up this menu here. So we have edit, sort A, sort D, clear list, set up editor, or whatever. All we want to do is we want to edit. Usually I would suggest you enter your data points in list 1. You can see here I have some numbers in list 2, but that's for a later example just because it's going to take some time to type them in. I'm trying to save a little time here. But our 5 data points were 2, 3, 3, 8, 10, 10. So under list 1, I type 2, enter. You see it pop up there. 3, enter. See it pop up. 3, enter. 8, 10, 10. And then just check your list before you go to the next step here, because I know these calculators can be a little bit touchy. So you want to make sure that you have the correct numbers. So 2, 3, 3, 8, 10, 10. So we're good. Once you have those numbers entered, you go second quit, back to the home screen. Now we're going to hit that stats button again. But this time we're going to go over to calculate. And we have a long menu of options here. But the one we want is the first option. We want one variable stat. So we're going to hit enter. And you'll see here, so list 1. So that's why I would enter all my stuff into list 1. I'll show you how to switch to list 2. But as long as if you do everything in list 1, it's not going to matter. You never have to switch what list number. You don't have to have anything where it says FREQ list. So just arrow down to calculate, so it's highlighted, hit enter, and then you have all these options. So again, here's where the symbols are important. If you can do the calculator work, but you don't know what numbers you're looking for, you're kind of in trouble. But you can see here at up top, we have X bar. X bar is the mean. So our mean is 6. And then we have the sum of X. We have the sum of X squared. We have the standard deviation for the whole thing. Well, yeah, that's something completely different. So you can skip the S of X, thinks that really doesn't apply to you. But then the next one, we have sigma of X, but sigma, represents standard deviation. So there you can see 3.42, and then it tells you N, the number of data points. And then the rest of this would be to make a box and whisker plot, or will help you make a box and whisker plot if you have to ever do that. So we can see here when we type our information in your calculator. Now this is kind of an older calculator, but if you have a TI-84, this is kind of what you would expect to see versus using an iPad calculator. But you can see here we had X bar is 6, so that's our mean. And sigma of X is our standard deviation. So much easier than doing it by hand. So I'm going to skip this example because it really has no context. It's just some points, but you can use this example to practice typing things into your calculator, or you can jump down to what we call 12.3, which is using the mean and standard deviation. And it's the exact same thing, except now we're going to put a little meaning behind the standard deviation number at least. So the Maui News gave the following costs in dollars per day for a random sample of condominiums. Condos, man, must be an English class here. You gotta use the big words. Condos located throughout the island of Maui. Okay, so you can see 89, 50, 68, and so on. So it says compute the mean and the standard deviation. So I'll show you how to get back there, but I've already entered the list. I cheated here. So hit stats. We want to edit a list, so it's already highlighted. Hit enter. Now for you, I would enter those data points into list 1. You already have numbers in list 1, so if you want to clear them, arrow up so L1 is highlighted. Then just hit the clear button, hit enter, and the whole list is gone. So if I were you, I would re-enter those numbers into list 1 from the new example. For me, I put them all here in list 2 so that I could save some time and show you how to switch lists if for whatever reason you want to keep a list on your calculator. So we'll go second quit. My points are entered. Pause, enter those into your table. Then we're going to go to stats again, but this time we're going over to calculate. We want one variable stats, so we'll hit enter. Now, I put my information in the list 2. So if you kept yours in list 1, you just go down to calculate, hit enter, and you're good to go. But for me, my list is list 2, so I need to clear that. I need to hit second and then stats, because you can see in the top left corner of the stats button there's a list button, and that allows me to change my list to whichever one I entered the information. So mine was list 2, so I just hit enter. So now you can see my list changed to list 2. So I'll go down to calculate, hit enter, and we found the information that we're looking for. So the first one that we want was the mean. The mean is X bar right here at the top where the cursor is flashing by, so 136.15. So add that here, 136.15. So that's the mean. The next one we're looking for is sigma, the standard deviation. So if I hop back over to my calculator, you can see it right above n. It says 130.1776767, but let's round to 2 decimal places, so go 130.18. So you can see pretty quick graphing, or not graphing, but finding mean and standard deviation on your calculator. Now the new thing here in this 12.3 section, but it all goes together, is what does the standard deviation tell us about our data. So this is where the standard deviation can become useful. So in this specific example, we could say that since I'm going to abbreviate, standard deviation is large, this means the data is widely spread out. Okay, so the average was 130, the standard deviation, or the 136, the mean was 136, the standard deviation is 130, so like this is just going to be a terrible representation. It has nothing to do with this specific example. But let's say that I make this graph here. This line represents the average price of a condo, 136. It's just a straight fee, or a straight average of 136. So what is a high standard deviation? A 130 is very, very high for a standard deviation. What that means is the data points are spread out all over the place. So I could have a condo way up here. It's way more expensive, but then I have a few towards the average. I have some way out here. I'm all over the place. The data points are not very close together. Now, what you're looking for in standard deviation, so again, let's say that this is my standard deviation. What I'm looking for is values are very close to that average, or maybe exactly the average. So what you want, and I'll put this down here too, just as a note, standard deviation, I'll abbreviate again, closer to 0 means consistent data. So that's all it means. It means you're more consistent. So our standard deviation here was 130. Let's say that standard deviation was 20. 20 is still a pretty high number, but it would be a lot more consistent than 130. And you can see in the prices just by looking at it, the average, we said it was 130. Okay, that was our calculated average. We have one here that's at 500. That's way above the average. We have one here that's at 40. That's way below. When you find your average and you start seeing numbers that are way away from that average, your standard deviation is going to start to creep up. And then you can see here like another 375, and then we have one here that's 2 here that are 45. So you can see how the points jump up and down. But that is it for section 12.2 and 12.3.